Good morning, class. Today we will continue exercise 3.1 of understanding quadrilaterals. Okay, so the first question of the exercise, some figures are given to us and we have to classify each of the figure on the basis of the following, that is simple curve, simple closed curve, polygon, convex polygon and concave polygon. So if we see the first figure, I can classify the first figure as the simple curve, that is A. Again, I can classify the first figure as simple closed curve, that is B, the polygon, that is C, and the concave polygon, that is E. Now, if I come to the second figure, of course, first of all, it is a simple curve. So, A, it is a simple curve. It is a simple closed curve. So, B also is applicable here. Now, if we come to C, again, it is a polygon. So, C is also applicable, and a concave, not a concave polygon, it is a convex polygon. So, D option is also applicable here. If we come to the third figure, in the third figure, it is not a simple curve, neither a simple closed curve, neither a polygon, and neither convex or concave polygon. Same is the case with the fourth. Now, if we come to the fifth figure, it is a simple curve, that is A, and it is also a simple closed curve, that is B. Neither a polygon, nor a convex polygon, and nor a concave polygon. Coming to the sixth question, it is a simple curve, so A. It is a simple closed curve, that is B. Now coming to the seventh question, seventh part, again it is a simple curve, that is A, and it is a simple closed curve, that is B. Now eighth part, it is neither a simple curve nor a simple closed curve nor a polygon, and neither a convex or a concave polygon. Okay, now come to the second question. How many diagonals does each of the following have? Now, there is a general formula for the number of diagonals of a polygon. Number of diagonals in any quadrilateral or any polygon, that is equal to n into n minus 3 upon 2, where n stands for the number of sides. N stands for the number of sides. Now, if you take the first part, that is A part, a convex quadrilateral. In the case of convex quadrilateral, if we talk about the number of sides, that is n is equal to 4. So, the number of diagonals, if I put the value of n, that is equal to 4 in the formula, number of diagonals will be equal to 4 into 4 minus 3 upon 2, that is equal to 4 into 1 upon 2, that is equal to 2. Orally also we know that in any quadrilateral the number of diagonals are 2, but by the formula also we have proved that the number of diagonals in the convex quadrilateral is 2. Second part, the B part, we have to find the number of diagonals in a regular hexagon. If we talk about the regular hexagon, hex means 6, so the value of n, that is number of sides, is equal to 6. So if we talk about the number of diagonals, I have to put the value of n, that is equal to 6 in the question, in the formula, that is n into n minus 3, 6 into 6 minus 3 upon 2, that is equal to 6 into 3 upon 2, that is equal to 9. So the number of diagonals in the regular hexagon is 9. Now coming to the C part, that is triangle. If we talk about the triangle, the number of sides, that is n, is equal to 3. We orally also know that the number of diagonals in a triangle is 0, that is it is having no diagonal. By the formula also we can prove it. If the number of diagonals, if I put the n equal to 3 in the formula, so number of diagonals is equal to 3 into 3 minus 3 upon 2. So 3 minus 3, that is 0. So the number of diagonals in a triangle is 0. Okay, now the next part, the third part, what is the sum of measure of the angles of a convex quadrilateral? If we talk about the convex quadrilateral, say this is a convex quadrilateral. If we talk about the number of the sum of the measure of the angles, I can divide this convex quadrilateral into two triangles. So the sum of angles of first triangle is 180 degree. I can say A, B, C and D. So if I consider triangle ABC, so sum of angles is equal to 180 degree because of the angle sum property. And if we consider angle triangle ACD, sum of angles is equal to again 180 degree. So I can say that the sum of angles in a convex quadrilateral is equal to 180 degree plus 180 degree, that is equal to 360 degree. Now coming to the next part, it is asked that will this property hold if the quadrilateral is not convex? That is, it is asked that if the quadrilateral is concave, this property is applicable or not. If I draw a concave quadrilateral, this is a concave quadrilateral. Now again, if I have to find the sum of angles of this concave quadrilateral, again I can draw this line joining B and C. Again, there are two triangles and the sum of these triangles is equal to, sum of the angles of these triangle is equal to 180 degree. So yes, this property is applicable for concave quadrilateral. Okay, now coming to the fourth question. In the fourth question, a table is given to us and each figure is given, and according to the figure, the number of sides and the angle sum is given. So we have to say, can you say about the angle sum property of the number of sides according to the number of sides? And now if I see the pattern which is given, if the number of sides is 3, the angle sum property, that the sum of the angles is 180 degree. If the number of sides is 4, the sum of angles is 4 minus 2 into 180 degree. So I can calculate a general formula for finding the angle sum of the any polygon. So the general formula, that is equal to 2n minus 4 into 90 degree, or I can say n minus 2 into 180 degree, where n stands for the number of sides. Now if I talk about the n is equal to 7 in the first case, as number of sides is equal to 7, so angle sum of a convex polygon having number of sides 7, so I can calculate it 7 minus 2 into 180 degree, that is equal to 5 into 180 degree, that is equal to 900. Coming to the second part, n is equal to 8 in this question. So putting the value of 8, n means number of sides. So number of sides are 8. Putting the value in the general formula, I will get 8 minus 2 into 180 degree, that is equal to 6 into 180 degree, that is equal to 1, that is equal to 1080 degree. Now coming to the C part, that is n is equal to 10, that is number of sides is equal to 10. Now again putting in the formula, 10 minus 2 into 180 degree, that is equal to 8 into 180 degree, that is equal to 1440 degree. Now coming to the last part, it is asked that if number of sides is n. So I have deduced the general formula. If the number of sides are n, so the angle sum will be equal to n minus 2 into 180 degree, or 2n minus 4 into 90 degree. Okay, come to the next question. The fifth question, what is a regular polygon? Now if I can define a regular polygon is a polygon which is having equal number of equal sides and equal angles. That is, all the sides are equal in measure and all angles are also equal, then it is a regular polygon. Okay, now state the name of the regular polygon if n is equal to 3 sides. That is, number of sides n is equal to 3 in the first part. So if n is equal to 3, I can say that n is equal to 3, that means a triangle in which all the sides are equal and also all the angles are equal, then only it is a regular polygon. So if all the sides and all the angles are equal in a triangle, so it is a equilateral triangle. Okay, second part, n is equal to 4, that is number of sides is equal to 4. Now if n is equal to 4, we all know that in a square number of sides is equal to 4, and also in the square all the sides are equal in length and all the angles are also equal, that is equal to 90 degree. So the example is square. The third part, in the third part, n is equal to 6, that is number of sides is given as 6. So it is a regular hexagon. N is equal to 6, and if all the sides are equal in length and all the angles are equal, then only it is a regular polygon. So I can say the example for n is equal to 6 is regular hexagon. Okay, so for n is equal to 3, it is a equilateral triangle. For n is equal to 4, it is a square, and for n is equal to 6, it is a regular hexagon. Okay, thank you all of you.